And welcome back as we go ahead and dive into our next programming topic, which is that of arrays. And so we're actually going to twofold this. Today we're going to not only look at how to create an array, but we're going to start taking our first look at how to use them as well. So let's first off by asking the question, what is an array? Well, an array is a data structure used to process a collection of data that is all the same type, such as a list of numbers of type double or a list of strings. In fact, there are more data structures out there, but the array is the most primitive, easy version for us to learn first before we get into more complex data structures later on. Now, we haven't seen arrays being used so far in any of our programs, but they are a very fundamental concept in many different programming languages. So the question you might ask me is, why do I need to use an array? Why should I use it? I could just write a class or write a loop or something like that. Well, let's just say, for example, we want a program that reads in, let's say, 5 test scores and performs some manipulation, like maybe it's going to find the average of these scores, or maybe it's going to look for the max or the minimum. Let's just say we want to look at the highest test score, and then we want to output the amount by which each score falls short of the highest, so we're looking for the range for them. Well, the highest score can't be known until all 5 scores are read in. Hence, all 5 scores kind of have to be retained in some way so that the highest score is computed and each score can be compared to it. So to retain the 5 scores, we'll need something equivalent to 5 variables of type int. Now, we could use 5 individual variables of type int, but keeping track of 5 variables is hard. And let's say we later want to change our program to handle 100 scores, or we want to handle, let's say, 1,000 or whatever. Either way, the larger our variables become, it becomes very impractical at that size. So a better idea is to use an array. So when we start looking at how we can use these arrays, an array is going to behave, the way to think about it is like a list of variables with a uniform naming mechanism that can be declared in a single line of code. The names for the 5 individual variables might be like score 0, score 1, score 2, score 3, and score 4. Now the part that does not change, in this case score, is the name of the array. The part that can change is the integer or the value that we have in that square brackets. So when we talk about creating and accessing arrays, in Java, an array is a special type of object, but it's often much more useful to think it instead as a collection of variables all the same type. Now, an array that behaves like a collection of the 5 variables of type double could be created as follows. Double score equals new double 5. This is like declaring the following 5 variables to be type double. Score 0, score 1, score 2, score 3, score 4. Now, each of those pieces have different components when we looked at that variable. So we have an index, elements, and a length. The individual variables that make up the array are referred to in a variety of ways. We're going to refer to those variables as index variables, so like score of 0, score of 1, etc., though they are sometimes called subscripted variables or more often elements of the array. The number in the square brackets is of course referred to as the index or the subscript. In Java, indices are numbers starting with 0, not any number. A common misconception is that arrays are going to start at position 1, but they don't. They start at 0. So keep that in mind. It's a very common thing. Just like when we look at strings, we had a similar thing. We start that first position is always at 0. Now, the number of index variables in an array is referred to as the length or the size of the array. So let's look at the length of the array with a little bit more detail. When an array is created, the length of the array is given in square brackets after the array name. So when we had our double score 5, that 5 is referring to the length. The index variables are then numbered using square brackets starting with 0 and ending with the integer that is 1 less than the length. And the reason why we say 1 less than length is because, remember, arrays start at position 0. Because they start at 0, you're not going to have that last score be score 5. It's why it's score 4, because we start at 0. And we can think of this very similar to like how we discussed string.length, that method. The class creates and it actually uses an array, and that's the reason why when we said that a string has an empty string of length 0. That's because it's technically still occupying a value within that array. So to really help put some context to this, let's look at this with an example on array. So here we have an array of type double called score. So double square bracket score equals a new double square bracket 5. You'll notice that it's set to an indexed array of size 5. Now you can use any expression that evaluates to a non-negative int in place of the 5 in square brackets. You could even have it be a variable, for example, defined from the user. So if the user says, you know what, I want this to be, size 12, and that variable, let's say, was array size, then you could put in that square brackets the variable array size and would hold that value. As I already mentioned, you can read it from the keyboard and use the variable in this place. The reason why we want to do this is because the size of the array that can be determined when the program is run, rather than be statically assigned as we have here. The next thing to discuss is the base type of an array. So an array can have index variables of any type as long as they are all the same type. This is referred to as the base type of the array. In our example, the base type of the array is double because it's double score. To declare an array with base type int, all we would do is simply type the name int instead of double when the array is declared and then created. The base type of an array can be any type, including a class type. So you could have a string array, we could have a date class array, we could have a person array, a pet array. Whatever the name of your class is could be an array object. Now let's discuss those index variables with a little more purpose. Each of the 5 index variables in our example array score can be used just like any other variable of type double. So all the following would be allowed in Java. So if I had score 3 and I said I want to make that 32, I would then change whatever value is currently in there to 32. If I say score 0 is equal to score 3 plus 10, it's going to take whatever's in score 3, add 10 to it, and store back in score 0. And then the system.print line would then expect it to print out. So the 5 index variables in our sample array score more than just 5 plain old index variables type double. A number in square brackets is part of the index variable's name, and your program can compute the name of one of those variables. So when we go back to our discussion on creating an array, instead of writing the integer constant in square brackets, you can use any expression that values an integer that's at least 0 and at most 4. So the following would be allowed. System.print line score index is at position index. Index, of course, referring to that number. Index is a variable of type int, specifically has been given either the value 0, 1, 2, 3, or 4. Because remember, our score array we set to size 5. When we refer to these index variables grouped together into one collective term, though, remember we're going to refer to this as an array. And we can refer to the array named score without using any square brackets. So if I wanted to simply just refer to score as the object, I don't have to say score index or anything like that. I can just simply say score to reference that variable. Now the program array scores that we're going to look at here in just a second is going to show us an example of how to use our sample array score as 5 index variables, all type double. A couple things real quick to make sure we show up and make sure we have a good understanding. When we're talking about declaring and creating an array, if you look at this documentation here, one of the things you'll notice is that when we are doing our syntax here, it's always the base type with square brackets, the name of the array equals new base type, and then the length. Base type, of course, refers to whether it is a primitive type, such as int, double, char, or it is a class type, such as string. And if we look down in here, we can see we have some examples. So, for example, you can see here's a char array, we have a double array, and we even have a person array with the note that person, in this case, is a class. Now, when we talk about these square brackets, this is a notation that's a little different from other things that we've been doing. You'll note that the program can compute the name of an index variable by using a variable as the index, such as in the following for loop. For index equals 0, index is less than 5, index plus plus, system.print line, score of index, differs from the max by max minus score of index. Now, when you look at this, do not confuse the 3 ways to use the square brackets with an array name. All right, because one of the things you'll notice is these square brackets right here are referring to what? To index. Index, of course, is this variable being passed up here that we're using for this loop. So when I go through this loop the first time, index will be 0, which refers to that first position in the array. Once it goes to that next iteration, we're going to change index to 1, which then refers to the second position in the array. Another thing to note is that the square brackets can be used to create a type name, such as the double bracket in the following double bracket score. Second, the square brackets can be used with an integer value as part of the special index Java uses to create a new array, as in score equals new double 5. The third use of square brackets, of course, is to name an index variable of the array, such as score 0, score 3, and says divided by the following, max equals score of 0. So these are the three ways that we kind of see these square brackets that are here in our code. And again, it's something just a little different than we're used to doing, because most of this point we've been using more parentheses and things like quotations. When we ever see brackets, these are things we're typically going to refer to more when we're working with arrays. Now, as we have mentioned previously, the integer inside the square brackets can be any expression that's evaluated to a super integer, such as following. In x equals 1, score, x plus 3 equals 100. So brilliant score position 4 is score plus x plus 3. X plus 3 would mean then when this program actually runs, it's going to take this value in here and find it at where? Score at 4, because it's going to evaluate this next plus 3 in order to determine where exactly are you looking in that array. You'll also note that in this code here, next plus 3 and score 4 are the same index variable, because again, as we already mentioned, x plus 3 evaluates 4. So you might be wondering, why are we doing this? Well, there's going to be times when we come into much more advanced programs when we may not want to look just at that variable we currently are at. I may not want to look just at 4. I might want to look at where I'm currently at, and maybe want to look at the variable next to me. So that might be, in this case, instead of x plus 3, be like x plus 1. I want to compare two variables that are side by side and see what I want to do with them. Maybe I'm doing something like seeing if one is bigger than the other. And lastly, let's just talk real briefly about visualizing an array so you can kind of put some context to how this actually works. And this is our visual representation of an array called score. You'll notice we have indices going from 0 to 4, because remember, arrays start at position 0. If you look, for example, at score 3, this is a specific variable in this array, we have the value 100. And the length of this array would be 5, because again, remember, even though we started at 0, if we look how many pieces do we have here, we have 1, 2, 3, 4, 5, which allows us to know that this is length 5. And lastly, let's just take a real quick look at the array of scores class here. You can see we, of course, are setting this up with getting a input here. And we created our array right here. So we have double score equals new double 5. I have an int called index and a double called max. We're going to enter in 5 scores. And so we are going to start first by getting score of 0 and setting that to our next double. And the reason why we want to do that, because then we say we're going to set the max equal to score of 0. And that allows us then to do that comparison that we can do later on. So then we are going to start at 1, because we already have that first value of the array, and we're going to then fill that with more user input. And as we do that, we're going to actually compare that new value with the max value, and if it is larger, we're going to update max. If it's not, it won't do this because it won't hit this if statement here. Then it's simply just going to print out the highest score is whatever the max is, and we can also, of course, print out the scores. And then, of course, it's simply going to go back through that array. So we have score here again. We're using index, and notice this time we're starting at 0 instead of 1, because here we have to traverse the whole array this time. So let's give this a run just to see what we get for output. And so we'll enter in 5 scores. I'm going to make this pretty easy. Let's just do 1, 2, 3, 4, and 5. And so we get the highest score is 5. These scores are 1, which differs by a max of 4, 2, 3, 3 differs by a max of 2, 4 differs by a max of 1, and 5 differs by a max of 0. And again, other thing you'll notice is that these values here are all double, because remember, what type is our array? The type is a double. Even though index is an integer, It doesn't affect the actual output of what this array is. But this is, again, a quick introduction to everything with arrays. It's a lot of information to process, but of course we're going to have a lot more practice, and this whole chapter will be dedicated to us building and working with arrays.